Okay, so second section we'll look at this week is 7.3. So today we'll be solving equations, some inequalities towards the end, graphically. The nice thing about graphically is you pretty much can solve anything that they give you, because all you have to do is graph it and look for one of two things. Either an intersect, if it's like a y1 and y2, or if it's equal to 0, you're going to do second calculate 0. Okay, either way. Later on, we'll get into solving the same kind of problems using algebra. But for today, we'll use a graph. So we have to keep the idea in mind about how many solutions we have. If you can find one solution to a trig equation, to a periodic equation, how many solutions does that mean there really are? Yeah? Infinite. Okay, so if you can find one, there's really an infinite amount if you're dealing with a periodic equation. So the idea is you have to find all the solutions in the first period. Okay, so find all the solutions you need to in one section, within one cycle, and then once you have each one of those solutions, you take into account the period to represent all solutions. So what does that mean? We usually put plus the period times n. What's going to be a little different today is we're going to have to figure out the period. Okay? And we're going to deal with functions we've never seen before. Like we've never graphed sine squared or cosine cubed. So we might know what the period of sine and cosine are, but we don't know what happens when you raise it to a higher power. Okay, so we'll look at that. Okay, so that second step basically means put plus the period times n. You can put plus period times any letter. I think sometimes our book uses k, but just understand the letter represents an integer. Okay, so let's find all solutions to this one. Now we've looked at it a little bit algebraically. We haven't looked at real complicated ones algebraically. That's where you use the ASTC diagram. But that's for algebra. Okay, so we're going to solve it just with a graph. All right, y1 and y2. So let's type it in. Okay, and I'm going to do it in radians. So set my mode to radians. I've got sine already typed in. Put in 0.8 into y2. And now for sine, what's the period of sine? Yeah. Okay, 360 degrees, or for the mode that we're in? Leo?
2 pi radians.
2 pi radians, yes. So you'll know if you've done this right, because if you see one cycle on the screen, you've set your x max and min correctly. If you see more or less than one cycle, you didn't. Okay, let's hit graph. And that looks like it's going to be perfect. Okay, we're seeing one cycle. Okay, and the directions I wrote said find all the solutions in that cycle. So let's go second calc, intersect. Okay, I'm going to do the second one, the one further to the right. If someone else can do the one more to the left, that would be great. Okay, so the one further to the right is 2.21 radians. But that answer is going to keep repeating every cycle. And we just said the length of a cycle is 2 pi. So put plus 2 pi n. And if n was a negative number, you could find answers in the cycles before. Think of subtracting 2 pi. You could move back to the left. Okay. And now I need that intersection point for the left one. Okay, does anybody have the other intersection point? Yeah. 0.93. Okay. And that represents all the solutions. Any questions on what we did there? Okay, we've kind of done these basic ones before. Now after this, we'll get into ones that are a little more complex. Right, so in this particular problem, we did a second calc intersect. The reason we did that is because we had an expression on the left, we had an expression on the right, and neither one of them was 0. If you had something like this, okay, we'll get to this one in a little bit. Everything is on the left. So really all you're going to use in this problem is y1. And instead of calculating an intersect, you're going to second calc a 0. You're going to calculate where it crosses the x-axis. Right? So it's a little different in the steps on the calculator, but it's really the same idea. Okay? All right, so whenever you're solving an equation and it's equal to 0, the directions for something like that could say find the roots of the equation, okay? Or calculate the zeros of the function. So remember, zeros, if you want to think of it visually, that's where your graph crosses the x-axis. Another way to think about it is you could say a 0 is the number you plug in for x, do out the calculation, and you get 0 for y. So if we have a periodic function, something like, let's say we had, let's just say, like sine. Okay, if you had sine, you had cosine, you had tangent. If you had any of those types of things in as a function in your equation, then what you're solving is a periodic equation. This is not a periodic equation. X squared plus x minus 2. It's just a parabola. It doesn't have a repeating behavior to it. If I did something like this, that's periodic. It's a sine function. It's been phase shifted, but that doesn't matter. The key is right here. Periodic. And so if you have a periodic function in your equation, then you have a periodic equation. All right, so this part, I would look at it first before you decide whether you need to copy it down. All it's saying is that if you have a problem, first thing you have to do is calculate all the individual solutions, just like we did right here. So calculate the solutions first, and then put plus period times n. That's exactly what we just did right here. Period times n, period times n. That's all that's saying. Okay, so find all solutions in one period, and then write all the answers just like that. And you have to write as many equations as you have answers. Okay? I think the most we're going to have today is probably 6 different answers. We'll have a problem where it crosses the x-axis 6 times, and you do need to calculate each time. So you gotta, it's more time consuming than anything else. On a test, I probably wouldn't give you one with more than like 3. Just because if you can second calc 0 once, I'm sure you can do it 6 times. It's the same thing. Okay. So any questions on that That idea. All right. Well, the only time you don't have to write plus the period times n is if they specifically say in the problem, find all solutions between, say, 0 and 10. If they say to just find answers between 0 and 10, that's all you have to do. Just write down everything between 0 and 10. Don't put plus period times n. That's only if they ask for all solutions. So when we look at a problem like this, it's a little more complicated. Okay. This is periodic. How do I know that? It's got a cosine term and it's got a sine term in it. Those two things I underlined are going to cause repeating behavior in that equation. So how do you figure out the period of that entire thing? Cosine squared has a period. Sine has a period. But they might be different. So how do you take them both into account and find the period of that entire equation? Well, first thing you want to do is find the period of each periodic term. Okay. On the other page, I underline the periodic terms, cosine squared and sine. One is not a periodic term. One is just a number. Okay. So when you think periodic terms, think trig. So find the period of each term. And then the period of the entire problem is the least common multiple of all the individual periods. So remember, LCM, least common multiple, you're trying to think of a number that two things divide into without a remainder. Like, if I said, what's the least common multiple of 2 and 3? Trying to think of the smallest number you can that 2 divides into and 3 divides into without a remainder. Here would be 6. That's the smallest multiple they both have in common. 6. All right, so what we have to do first is just kind of investigate a little bit. Sine, what do we have? Cosine squared? Cosine squared. Okay, let's draw it out and see if we can figure out the period of it, okay, without all the other stuff. Let's just graph cosine squared all by itself. So let's type in cosine squared. And the way you have to type it in is like that. Make sure you close your parenthesis. If you don't, it would do this versus doing this. I want what's on the right, not what's on the left. Okay, so let's graph it. And let's set a window from 0 to 2 pi and see if we can tell how many times it repeats. If the graph only repeats once, then we know the period is 2 pi. Okay, but let's check and see. Okay, so there's the graph of cosine squared. How many times is it repeating from 0 to 2 pi? Yeah.
Twice.
It's repeating twice. So if a graph repeats twice from 0 to 2 pi, what does that mean the period is?
0 to pi.
0 to pi. Yep. If you go to the halfway point on that screen, you're seeing one cycle and then a second cycle. So we're going to come up with a way to figure out the period a little easier in a bit, rather than just investigating and trying to figure it out. There's a formula to do it, and I'll show you that. How about the period of sine? What's the period of the basic sine function? Yep,
2 pi.
2 pi. So now, what's the least common multiple of pi and 2 pi? Yeah,
2 pi.
2 pi. That's the smallest multiple they both have in common, 2 pi. If you start listing the multiples of pi, you would write 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. And then if you list the multiples of 2 pi, you have 0, 2 pi, 4 pi, 6 pi, 8 pi, and so on. Well, the smallest one they have in common, besides 0, because 0 is a multiple of everything, ignore that one, is 2 pi. Okay, so now that we know that, that's what you need to put on the end of each answer, plus 2 pi n. Because that's how often this repeats. Now we need to graph the whole thing. So if you already have cosine squared in, you could just second insert a 2 in front of it. And then go to the end. Plus sine of x. It's important you close the parenthesis, because if you don't, you're going to create a phase shift. It's not x or t plus 1 in parentheses. It's t, end the function, and then a plus 1. Okay, that's what you should type in. Our window should be one cycle of that function, which we know is 2 pi. So you can set your window however you want, as long as when you take x max minus x min, the difference between them is one cycle. If you want to go 4 pi to 6 pi, that's okay. I usually just go from 0 to 2 pi. But anything that's a width of 2 pi works. High and low, we don't really know. So let's just try negative 2 to 2. And if that's not good enough, we'll adjust it. Well, I think it's probably good enough to see where it crosses the x-axis, but it's not really good enough if you want to get an idea of what this looks like. So I'm going to set the y max. Let's try 5. Okay. So that's what this graph looks like. It's going to be repeated copies of what you're seeing right there, bless you, over and over. Okay, so now the question is, where does it equal 0? It's right there. I'm going to zoom in just to see if it crosses twice. I have a feeling it only crosses once, but you never know if it comes down and then back up again. So let's just try to get a little closer. Zoom in. Yeah, I think it's just crossing once. So second, calc 0. Pick a point enough to the left of where you think it crosses. Okay, get a point a little bit to the right. And then the guess, it doesn't really matter because you've already specified the start and the end point. If your guess is closer to where the answer is, it'll do it a little faster. That's all. Okay, so we get a 0 at 4.71. Okay, so in this case, t is about 4.71. And how often is that answer going to repeat itself? Yep.
2 pi n.
Every 2 pi. Yep, every cycle. So this particular problem only has one answer per cycle. That's all. Any questions on that? Okay. So again, we're going to come up with a formula for how you can figure out what the period is. And it really, all it has to do with, are you raising to an odd or an even power? That's what it all comes down to. Okay. All right, let's try this one. Okay, a couple things you could do. You can leave it the way it is, which I mean, it doesn't matter. If you want to leave it the way it is, that's fine. Or if you want to get it equal to 0 and make it like the last problem, we can do that too. So can somebody tell me, how could we move 3 cosine x to the left so that this was equal to 0? How about Dylan?
Subtract 3 cosine x from both sides.
Yeah, just subtract 3 cosine x from both sides. And the reason why you might want to do that is because now you can actually see a picture of what this looks like. If you graph the left in y1 and graph the right in y2, you're graphing two different pictures. You don't really see the combined effect of what it really looks like. Not that you can't solve it that way, but I want you to see the picture here. Right, so let's look at tangent. Does anyone remember what the period of tangent is? It's different than sine and cosine, yeah? It's pi. Cosine is 2 pi. And this situation tends to happen a lot. Okay. What's the least common multiple of pi and 2 pi? We just did that in the last one. Yeah? 2 pi. Okay, and 2 pi comes up, as I said, a lot. Don't think that it could always be 2 pi, though, because it doesn't have to be. But it does tend to come up a lot. Okay, so we've got that. So now I'm going to graph tangent x minus 3 cosine x. And clear it first. Tangent x, close parenthesis, minus 3 cosine x. Now, what's different about the tangent function compared to like sine and cosine? Something very, very different, yeah? It has asymptotes. It's not a continuous function. So if you throw something in that's non-continuous, all of a sudden now your graph is going to have breaks. Unlike the other graph, it was just a connected wave. Okay, period, we zoomed in, so I need to fix that. Okay, and how high and low is it going to go? Well, it's going to have asymptotes. It's going to go up and down forever. So let's just try -8 to 8 and see how it looks. And you're going to see sections of that repeated over and over. Definitely periodic, but it's not a nice wave, and it looks a little different than regular tangent because you've thrown in that minus part. How many times does it look like that crosses the x-axis?
2.
Yeah, I think it's 2 times. There's really no confusion here. There's nothing tricky that you need to zoom in. It's crossing 2 times. So second calc, 0. Remember, you're not doing an intersect because you didn't type in something in y1 and y2. Okay, pick a point left. Pick a point to the right. Do our guess. And one of the answers is 2.13. Okay, directions. Find all solutions. So tell me how often that repeats. And you already did it every cycle. 2 pi. Okay, does anyone have the other intersection point, Sam? 1.01. And that answer is also going to repeat every 6.28 radians. Okay. Questions on that one? So let's try this one. But first, let's just graph sine cubed. Okay, just by itself. Just to see if we can figure out what's the period of sine cubed. So I'm going to put in sine of x cubed. Now, one thing that does complicate this one a little bit is that 2. Because we know that 2 is a horizontal stretch or shrink. Okay? So that 2 is changing the period, and the cubed is changing the period. The reason I'm not graphing them both at the same time is because if I do, you won't be able to tell what the effect of the cube is separate from the 2, because you'd be seeing them together. Okay, let's graph just the cube first. 0 to 2 pi. Okay, so if you look at that, how many times is that graph repeating from 0 to 2 pi? It's not. That's one cycle. Okay? It kind of goes up, it gets a little flat, it goes down, and then it comes back up to flat, where it's going to start over again. So that is one cycle. So sine cubed has a period of 2 pi. Let's throw the 2 in there and see what that does to it. Remember, when stuff is inside parentheses, it's the opposite of what you would think. That's a number bigger than 1. Bigger numbers should compress. So now this graph should look like it's compressed a little bit. Okay, how many cycles are we seeing there? Sam? Now we're seeing 2. So if from 0 to 2 pi, you're seeing 2 cycles, that means the period of this entire thing is pi. So cubing it didn't really change the period, right? Because sine has a period of 2 pi. Sine cubed without the 2 also had a period of 2 pi. So it turns out that if you take sine or cosine and raise it to any odd power, it has no effect on changing the period. Raising it to an even power does. And I'll give you a chart in a second that summarizes all of that. Okay, so sine cubed has a period of pi. Shauna, what's the period of just regular cosine? 2 pi. And Jay, in the least common multiple of pi and 2 pi? 2 pi. 2 pi. Okay. So now we know what to put on the end of each answer. Plus 2 pi n. All right, let's graph it and see how many times it crosses the x-axis. So I need a 3 in front of that. And then minus 2 cosine x. All right, so we want to set our window so that it's the same width as the LCM. 2 pi. Okay, we're good. Zoom in a little bit. Let's go -5 to 5. And we're looking for how many times it crosses. Okay, so what you're looking at is that's one cycle, because it ends right where it would start again. Same y value. Okay, how many times does it look like it crosses? Yeah, 6. Yeah, it does. It crosses 6 times. So you would have to go through and calculate second calc 0 6 times. Any questions on how to do that? Okay, so your solutions are, the first one is 0.5, which looks pretty good, halfway between 0 and 1. The next one is, let's see, 1.25, 1.57, 1.89, 2.65, and 4.71. And this is a little bit informal, but I'm just going to put a big plus sign, 2 pi n. And that represents plus 2 pi n on every answer you see there. Okay, if you were writing it more formally, like somebody really being picky, they would want to see plus 2 pi n written 6 times. Okay. Any questions on that one? All right, so that's solving with equations. Okay, with an equation, it's always x equals or approximately equals, and you list your answers. All right, so let's just summarize the general idea of periods. So for tangent and cotangent, it doesn't matter whether you raise it to an even or an odd power. You're always going to use the formula I'm about to show you. But if you have sine, cosine, secant, or cosecant, any of those to an even power, the formula to calculate the period is pi over the absolute value of b. And if you're wondering what b is, I think I mentioned it. No, I don't. I'll tell you what it is. So b is the coefficient of x. It's the number in front of x. So in what I've written here, all the coefficients are 1s. Okay, so for any expression that has anything that fits the patterns up above, use the formula pi divided by b to find the period. So what does that leave? Well, we've already covered tangent and cotangent. Doesn't matter if it's even or odd. But what we have left is sine, cosine, secant, and cosecant to an odd power. So if you have any of those to an odd power, the formula to calculate the period, 2 pi over b. And I put absolute value of b just in case the number in front of x was a negative. Because remember, the period is a length. You would never want to have negative length. That doesn't make sense. Okay, so any questions on when you use the formula pi over b to calculate the period? Or 2 pi over b? Alright, so I think that's a nice little chart, kind of summarizes it, makes it pretty simple. No matter what the power is, you should be able to figure out the period for any trig function. Alright, so inequalities. When we're solving an inequality, we pretty much do exactly the same thing when you do an equation. Except when you solve an inequality, your answer is not x equals a number. How do you write your answer to an inequality? What does an inequality usually have? Yeah?
Greater than, less than, greater than, equal to, less than, equal to.
Yeah, it has a greater than or less than. So what we're talking about when we solve an inequality is an interval. So if I had, actually this is a good one. So if I said to you, where is this graph less than 0? Not equal to 0, but less than 0. Well, I would say between 0 and 0.5. Then I would say between 1.25 and 1.57 in that interval. Between 1.89 and 2.65. And lastly, between 2.65 and the end of my screen, 2 pi. Okay. Those are all the intervals, or 4.71, not sure what I said, 4.71 and 2 pi. Those intervals that I just said are all the intervals where it's less than 0. And that's basically what we're going to do in the next problem. We're just going to write an interval instead of just writing those numbers. Generally, they're always going to give you a problem and ask you where is something greater than 0 or less than 0. And remember, the equation is periodic. So all those intervals that I named to you are going to repeat again in the next cycle. So do the same thing you would do as if there were equations. Put plus the period times n on each interval. Okay, also, we have to keep in mind vertical asymptotes. Because if you have a graph that has a vertical asymptote in it, you have to be careful when you write your interval. A vertical asymptote is always going to break what you would want to be continuous into 2 separate intervals. cannot have an interval that spans an asymptote. It has to stop at the asymptote, and then it can start again on the other side of the asymptote. But it can't just go through it continuously. This graph will have an asymptote. Cotangent. Tangent and cotangent, secant and cosecant, those are your graphs that have asymptotes. Okay, so the first thing we have to do is find the period of that inequality. Dylan, what's the period of sine to an odd power?
To pi.
Yep, it's 2 pi over b, and in this case b is just a 1, so it's just 2 pi. Cotangent to an odd power. About Sam, what's the period for cotangent to an odd power?
Pi.
So let's go back. So cotangent to an odd, perfect. He said pi, and it's pi over b. But remember in this case, b, if you want to write it, is just a 1. So, yep, good job. Pi. And Juliet, least common multiple of 2 pi and pi? 2 pi. So once you write your intervals, put plus 2 pi n on each interval. Now we need to graph it. I'm going to graph it so everything is on one side. So I'm going to graph sine of x minus cotangent x. All right, so there's sine. How do I type in cotangent? Because I don't have a button for that. Leo?
1 over tangent.
Perfect. 1 divided by tangent. So sine minus cotangent. So I just moved that right there. I want to know where my graph is less than 0. That's what we're looking for, because I moved everything to the left. Okay, window looks good. 0 to 2 pi. Hit graph. If you look quickly, you might say, well, wait a minute. Are those two curves the same? Did I set my window wrong? Am I seeing 2 cycles? But you're not. If you look closely, these 2 curves are different. They're not the same. Okay. So where are we less than 0? Well, we're starting right there. We're starting at 0. And I can always include the left end of my window. In general, you can always include one end of the window. If you include the left with a bracket, don't include the right, or vice versa. I always include the left. The very, very right edge of that window technically is a repeat of the very, very left edge. So don't include both. So we're going from 0 up to right there. That's my first interval where that graph is less than 0. Now I can go up to, and can I include that point? No. I have to be strictly less than 0. So whatever I get for that answer, it's a parenthesis. Okay, now we need it. So second, calc, 0. Pick a point to the left, to the right, and a yes. If someone can find the other one, we're going to need that in a little bit too. So from 0 to 0.905, if you want to be pretty accurate. Or there's another interval where we're less than 0. Somewhere around here up to here. But what's happening right in the middle of that graph that we have to be careful about? Megan? We have an asymptote. Now, in general, the asymptote could be kind of hard to find, but I'm always going to make it an easy number to find. My window is from 0 to 2 pi. To me, it looks like the asymptote is right in the middle. What's right in the middle of 0 and 2 pi? Pi. And if you weren't sure, check it. Go to your table, type in pi. It says error. There's an asymptote at pi. So, that asymptote is going to tell me where to start my next interval. Pi. And I cannot include it. You can never include an asymptote. Up to right there. That's where I'm less than 0. And I cannot include that point because I'm in a less than. Does anyone have what the second intersection is? Yeah? 5.38. Okay. So, that's in the first cycle, those are the intervals where you're less than 0. These answers are going to repeat again in the next cycle. So on each interval, just put plus 2 pi n plus 2 pi n. Okay. What does that really mean? Well, if you take and add 6.28 to every number you see on the board here, that'll give you all the answers in the next cycle. If you subtracted 6.28, you could get all the answers in the cycle before. And so on. You could keep doing that. Okay, but those are your answers. Okay, any questions on that one? I think these are the last two. That's a double. All right, let's do this one. This one's a little different. On the left, you have a periodic equation. On the right, you don't. So that's going to influence how you write your answer. Okay, let's just draw it and see what happens. And just leave it, the directions say to graph it as is. Just leave it the way it is. So sine 2x and x squared plus 1. I'm going to start with a zoom 7 and just see how it looks. So there's sine 2x. And there's x squared. Oh, I should have put in minus 1. Sorry. And what we're looking for is where the sine wave is above or equal to the parabola. Okay, so are there multiple sections where the sine wave is above the parabola, or just one section? What do you think, Gracie? There's just one. The parabola doesn't repeat over and over. Okay, you're not going to get like another copy of the parabola here and another one here. There's only one copy of the parabola. So the only section that the sine wave is above the parabola is from here to here. What I just highlighted in black. That is the only section where the graph in blue is above the graph in red. And that's it. So if you call, just to save a little time, if you call that A and you call that B, once you find your intersection points, that's the answer to this problem. Now, why did I put brackets instead of parentheses? Yep.
Because it's greater than or equal to.
Exactly. Not only can I be greater than the function, but I can also equal the function. If you go before A, so if you go to the left of A, the graph in blue is below. If you go to the right of point B, the graph in blue is way below the parabola. So the only section is between A and B. Okay, questions on that? Okay, this one. This is just a question I want to know how many times, if you draw that, it crosses the x-axis. So let's just type it in. It's the sine of 1 over x. I don't want to know what the solutions are. I just want you to tell me how many times it crosses. Sine of 1 over x. Let's start with zoom 7. Okay, how many times does it look like it crosses the x-axis? Any guess, Megan? About 4 times? Okay, I think it might be if we zoom in a little bit. Maybe that could help. So let's zoom in. All right. How many times does it look like it's crossing now? It's not very easy to tell. Let's set the window manually. Let's go from like negative 0.8 to 0.8 and graph that. I'm not sure that really helped either. So it's crossing a lot. Definitely crossing a lot of times. It's actually crossing an infinite amount of times. Infinitely many. No matter how much you keep zooming in, it's just going to look like it's crossing more and more. So it's crossing an infinite amount of times. Anybody tell me why? Why is that crossing an infinite amount of times? Well, as a hint, this is basically what you're looking for, right? Where is the sine of 1 over x equal to 0? That's what I just drew. Any question on just what I have written right there? That's what we're trying to figure out. So let's think about sine for a second. Think about the graph of y equals sine of x. Just the basic one. Does anybody remember a value for x that gives me a y value for 0? What's one number you can plug in for x and get 0 for y on the graph of sine? Sam? Yep. 0, 0. How about the one right in the middle? What's that x value? Dylan? Pi. How about the one at the end? What's that one?
2 pi.
2 pi. All right. What if I kept this graph going another cycle? What would that answer be? That's the next one. Yep. 3 pi. Hopefully you're seeing a pattern now. Let's do one more. What would this answer at the end be? That's the end of 2 complete cycles. 4 pi. So basically, any time that this argument is equal to, how would you describe these numbers? 0, pi, 2 pi, 3 pi, 4 pi. Yeah?
Multiples of pi.
Multiples of pi. So anytime that anytime 1 over x is equal to a multiple of pi, that's when you get a solution. Anytime that that's equal to a multiple of pi. So how would you get x by itself there? You could just take the reciprocal of each side. So the solutions are right there. Let n be any number you want, and you will get a solution. Let's look at the table, and I'll just show you. Let's let n equal 1. That'd be 1 divided by pi. If you type in 1 divided by pi, look at what you get. You get a 0. Let's let n equal 2. So 1 divided by 2 pi. I didn't type it in right. 1 divided by, in parentheses, 2 pi. You get 2 times 10 to the negative 13th power, which is basically 0. Okay. Let's do one more. 1 divided by 3 pi. 1 divided by, in parentheses, 3 pi. I get 0 again. 1 divided by 4 pi, 1 divided by 5 pi, 1 divided by 6 pi. What's happening is the denominator is getting bigger and bigger, or the denominator is getting bigger and bigger, so the overall fraction is getting smaller and smaller. So as you get smaller and smaller and smaller, it's actually crossing 0 faster and faster and faster. So another one, 1 divided by 1,000 pi. That's another solution. 1 divided by 1,000,000 pi. 1 divided by 1,000,007 pi. 1 divided by any multiple of pi is where this graph crosses the x-axis. So it's infinitely many times. So kind of a weird, kind of a simple looking equation, but actually a complicated result. So how many solutions are there? Infinite. Could do the same thing with cosine too. All right, so the last thing we'll look at is a double inequality. And with a double inequality, all you have to do is graph something in y1, y2, and y3, and you're kind of looking for where you have something sandwiched between two other things. Okay, so we'll graph that. What I'll try to do is do it in different colors so you can kind of see it. Let's do negative x. Let's do that in blue. I'll just put a line above it. Let's do x sine x. X sine x. Do that in red. And then we'll do x in black. So what we're basically going to look for here is where the red graph is sandwiched between the blue and the black. Now, what happens when you put a number in front of a trig function? What kind of transformation is that? If you were to graph 3 sine x versus sine x, what would the 3 do? Yeah? A vertical stretch. Well, that's kind of what's happening with that graph in red, except the vertical stretch is a variable. So this is a variable vertical stretch, meaning the height of this wave is going to change throughout the problem. I'm going to have to zoom out probably. Yeah, you can't really see much with that. Let's start with zoom 7. I think that'll be a little better. So there's negative x. There's x sine x. It's kind of hard to tell it's a sine wave, but if you zoom out one time, I think you can see it's a sine wave pretty clearly. It's just a sine wave where the height is constantly changing. And what actually happens is the height of this wave is bounded. It's trapped between these two graphs, the one in blue and the one in black. So let's look at that graph. Maybe move it down. And where is the graph in red below the graph in black, but above the graph in blue? Leo?
Whenever x is greater than.
Yeah, whenever x is greater than, now you can say equal to 0. Anything greater than or equal to 0, and it fits the criteria up above. All right, now let's try one more. Almost the same thing, except I'm going to change this to, I'm going to go to math, number, 1 and make it the negative absolute value. So I should have put that in first. And then the positive absolute value. Now, this is where graphing it in color is really going to help, because if I did this in black and white, I want you to tell me you tell me what you think would happen. So let me draw it in color so you can see it. So, if those two graphs were in black and white, and you put them on the same page, how would they compare? Yeah?
Well, the black and blue would be the same.
Yeah, so they would look like the same graph. Because it's in color, you can see that in the bottom one, the black graph is a V shape, and the blue graph is an upside down V shape. In the top one, you're getting V shapes, but it's not one thing. Like this top thing is not one graph. It's part of a blue line and part of a black line. You couldn't really tell that if it wasn't in color. It'd be hard to tell. Okay, so we've got the same setup. That's blue, that's red, that's black. So where is the red graph above the blue and below the black? It's actually the same question as last time. Where is the red graph above the blue and below or equal to the black? See it?
All the time.
All the time. So this one is all real numbers. And that's how you solve a double inequality. Generally, with a double inequality, you don't have to worry about intervals. You do it just like we did. All right, so tomorrow we will finish up 7-4. Thursday will be our planned review day, and then test on Friday. Okay, so the homework, make sure you write down the odds, because some of the intervals are just odds. So 401, 5 to 7, and 11 to 15, that's all. But 19 to 25 is odd. 29 through 31, that's all. And 33 to 37, that's odd.